All right, part 2 of your video key for the College Board multiple choice number 1 that I assigned. Starting on number 20 here, the function f has first derivative given by that. What is the x-coordinate of the inflection point of the graph of f? So inflection points on f prime are maxes and mins, or you can find the second derivative and find where it changes signs when it crosses the x-axis from positive to negative or negative to positive. Okay, so I don't think I showed any work here because I'm just looking at the graph, but there's the answer. So hopefully you can get that correctly. 21 is let f be a continuous function. Then the intermediate value theorem guarantees. So what we have here, we have a y value changing from -1 to 3 with x values from -3 to 6. So the mean value theorem guarantees that f of 0 equals 0. No, somewhere it equals 0, but not necessarily 0. I don't know why they would even say that. Here they tell us the derivative is 4/9. They're trying to get you to misuse the mean value theorem, which if you found, not necessarily misuse, sorry. So if you find the slope, 3 minus -1 over 6 minus -3 is 4/9. So the slope between those 2 points is 4/9, and therefore, because of mean value theorem, B must actually be true. Let's talk about why the others are not true. F has to be between -1 and 3, so it's saying all your y values have to be between -1 and 3. Well, that's not true. We could have, f of -2 could be -100 for all we know. We have no clue. There's not enough information to determine that. F of c equals 1 for at least one c between -3 and 6. Oh, sorry. This is saying the intermediate value theorem guarantees. So the answer is not B. That's the mean value theorem. So they are trying to trick you with mean value theorem. So for this one, does the y value have to equal 1 somewhere? Yes, it does because of intermediate value theorem. If it changes from a value of -1 to 3, then it must hit every value in between that. And then this one says, this one is kind of tricky. It says that the y value has to be 0, but then it limits the x values. Really, they're giving you the y values they gave. They're trying to confuse you. So that's not true. It's possible, but it doesn't have to be true. This is the only one that's guaranteed to be true. 22, let f be a differentiable function and let g be the function given by that, which is the following is equation of a line tangent. All right, so tangent line, you need slope and a point. Here's our g of x that was written on the other line. Make sure I have that. All right, so g of x is that, so let's find g prime. Product rule, the derivative of, so I'm using x and f of x are my two things being multiplied together. So the derivative of x is 1 times f of x plus the derivative of f of x, f prime of x, times x. And we're trying to do that at x equals 2. So evaluate this at x equals 2 gives us f of 2 plus f prime of 2 times 2. F of 2 we know is 3. This is information that's given right here. So we have our slope for g is 3 plus -5 times 2, which is -7. So that's our slope. And when x is 2, we have to find the y value for g. So g of 2 is equal to 2 times f of 2. Again, using this function right here. So g of 2 is equal to 2 times f of 2. F of 2 was given to be 3. So g of 2 is 6. So we have the point 26 and a slope of -7. And so you can just do point slope right there. And there's your final answer, which is answer D. Notice that they leave the answer in point slope. I'd say that's pretty typical. 23. All right, so this one, if you recall, the limit as h goes to 0, we did that when we were doing derivatives. So this is asking us to find the derivative of something. This is actually the same as this. Limit as h goes to 0 of f of a plus h minus f of a over h. Remember that? And so what this is saying is f of a plus h, where a is e. So our function is natural log of x at x equals e. And so f prime So we're finding f prime of e. So this is the derivative of that function at x equals e, which is answer A. Okay, so again, that's just recognizing this as being the limit definition for derivative, that thing that's highlighted right there. Okay, which is in general looks like this. So it's f of something, so that means our function, this f is this function right here. A plus h, well here's our plus h, so our a value is e, which means you're finding the derivative at e of the function that's right here, which is natural log. Okay, there's usually one like that where they're trying to get you to understand the definition of derivative when it's written as a limit. All right, which of the following is an equation of the line tangent to the graph at the point where f prime equals 1? So you have to find f prime. So this is, they're asking you to write an equation of a tangent line, but they don't give you the specific x value where you're supposed to find the tangent line. You have to find the x value. And so find the derivative 4x cubed plus 4x. And it says at the point where f prime equals 1. So we have to find where this equals 1. Okay, and go to my already worked out solutions here. And you just solve that graphically and you get x is approximately that. And then I had to plug that x value into here to get my y value. And then from there I do point slope. So they tell us the slope is 1. They don't tell us the point. So we had to find the point there. Okay, another tangent line question. 25. Oh, sorry, let's see here. Oh, on 24, they did not write it in point slope. So sometimes they keep answers in point slope form and sometimes they don't. So, you know, on this one, you just distribute the 1, which does nothing, and then add 0.115 to both sides. I did add a non-rounded version just to make sure, and then I rounded my final answer to that. 25, if f is a continuous function and the derivative of capital F is f of x, so what this is asking us to find is an antiderivative for f of 2x. Well, the antiderivative of little f is capital F because f prime is equal to little f. So it's going to be capital F of 2x, but when you do an antiderivative, if we were to do the derivative of this, our inside function right here, we would have to multiply by 2. So when doing an antiderivative, you divide by 2 instead, and you get 1/2 f of x evaluated from 1 to 3, which is 1/2 f of 6x, or sorry, not 6x, but 6, minus 1/2 f of 2. 1/2 f of 6 minus 1/2 f of 2, which the answer is E. Okay, if you didn't understand how I found the antiderivative there, well, watch the video again. But you could also set this up as a u substitution problem if you really wanted to and let u be 2x. And I'll let you work through that if you want. That might be helpful to some of you. 26, for all x in closed interval, the function f has a positive first derivative and a negative second derivative. Which of the following could be a table of values? All right, so if we have a positive first derivative, that means the function is increasing. If it's a negative second derivative, that means the rate it's increasing is decreasing, which means, like let's say it went from a value of 4 to 7. That's an increase, right? Then when it changes from 7 to something else, this is an increase of 3. It has to increase by less than 3. So it has to be any number less than 10 but bigger than 7. So it increases from 7 but increases less than it increased the step before. Okay? That's what is positive first derivative is increasing. Negative second derivative means it's going at a slower rate. So here the increase was 2, then it was 3, then it was 4. Well, our increase is supposed to increase at a decreasing rate, so it's not that one. Here we have 4, 3, 2. It's an increasing function, but the rates are decreasing, so it looks like that's our answer. Here, this is a decreasing function, so that's no good. D is a decreasing function, so that's no good. And E is a decreasing function. Because f prime is positive, it should be an increasing function. And so our answer is B. Okay. That's a typical type question as well. Understanding the connection between the derivative and second derivative by looking at a table of values. 27, the radius of a circle is increasing at a constant rate of 0.2 meters per second. What is the rate of increase in the area of the circle at the instant when the circumference is 20 pi? So we're finding rate of increase in the area of a circle. So area of a circle is pi r squared. So a prime is 2 pi r prime. R prime is 0.2. And we're trying to find it when the circumference is 20. So circumference, which is 2 pi r, is equal to 20 pi. Sorry, not 20, 20 pi. And that's just giving us our r value to be 10. So you get an r value of 10. So you can take r prime, r, plug it into this to get a prime. So it's a prime equals 2 pi times r, which is 10, times 0.2. And you should end up with 4 pi meters squared per second. There are units in this problem. Okay. 28. Okay, so let g be this function. And we're trying to find where it is decreasing most rapidly, what t value. So if we're looking where a function is decreasing, then we're going to look at g prime. So g prime is equal to, so the derivative of 100 is 0. The derivative of this is the derivative of sine is cosine. Keep the inside the same, pi over 2t, then multiply by the derivative of the inside, which is pi over 2, times that 20 gives me 10 pi. Okay, so that's 10 pi cosine, and then similar thing here. The derivative of cosine is negative sine. Keep the inside the same, multiply by the derivative of the inside, which is pi over 6, times 10, which is 10 pi over 6, or you could reduce it to 5 pi over 3, which I did actually on my handwritten version. And then we want to know, so this is where it's, if g prime is negative, that's where it's decreasing. And we want to know where it's decreasing most rapidly, which is just going to be the minimum of g prime. Because the most negative it is the fastest that it's decreasing. Because remember, the derivative is the rate. So you're looking for a minimum of the derivative where it's negative, though, because it has to be decreasing. Okay, and that final answer, I believe, was B. It for sure was. I just never circled it. Okay. 29. Okay, here's another problem like this. We saw 2 of these, I think, on the first video for the key to this. We're given f prime and asked to find a value of f. So since we know f of 0 and we're trying to find f of 2, and we have f prime, we're going to do the integral of f prime, because the antiderivative of f prime is just f. Choose our bounds to be what we know and what we're trying to find, because then the antiderivative of f prime is just f with the upper bound plugged in minus the lower bound plugged in. This is a calculatable value on your calculator. This is what we're trying to find, and f of 0 we know. Okay, so quickly, here's the work. Here's my number. Again, notice how I didn't round this. It didn't really matter in this because we're just going to add 1, so it didn't affect the outcome really, but it could. So don't use rounded answers for future calculations. Only round your final answer. And there we get answer E. 30. The graph of a function f is shown above. Which of the following statements about f is false? So f is continuous at a. Remember, to be continuous, we talked about this at the very beginning of the first video, the limit has to exist, which means it has to go to the same y value from both sides, which it does. So the limit does exist. Limit exists. Exists at a. And that's to say, whoa, I don't know what happened there. That's the same thing as saying the limit as x goes to a from one side is equal to the limit as x goes to a from the other side. That means the limit exists. But to be continuous, the limit as x goes to a has to equal f of a. Here our limit is this y value, but our f of a value is whatever that y value is. Okay, so a is false. Let's talk about why b, well, why the rest are true, actually. So b, there's a relative maximum at a. Well, yes, because right here, this point is higher than the points around it. Okay, so that's a max. X equals a is in the domain of f. Yep, there's a y value right there. The limit as x goes to a, which is, this is what I just said. D and C actually, D and E say the same thing. If this is true, then this is automatically true, because these two statements in D are the same thing as the single statement in E. So the answer there was A for number 30. 31, 3 graphs labeled. This one didn't copy over well for me. I don't know what it looked like on the website. It's still doable though. So we're given 3 graphs. We have to determine which one is the derivative of which. So remember, if a function, I'm going to talk about it in terms of colors here. I think it was a little easier. So let's call this one orange. Actually, let's just look at this because I already have colors. Keep them the same. All right, I did red, blue, green on the right. Red, blue, and green. Okay, so when something has a positive slope, its derivative should be above the x-axis, and when it has a negative slope, its derivative should be below the x-axis. So let's just start looking at red. Red has a negative slope this whole time, all the way to here, and then but green's not up below the x-axis, so it's not green. And blue is below the x-axis to start, but then when this changes to a positive slope right here, it still has negative values. So the derivative of red isn't on here, which means 1 must be f double prime, sorry, because its derivative isn't on here. So 1, f double prime is graph 1, or the red one. And then one of these must be the derivative of the other. So let's see, green has a negative slope all the way to there, and blue is below the x-axis all the way to there. Okay, let's just double check. This has a positive slope and then a negative slope, and green is above the x-axis the whole time. So green cannot be the derivative graph of blue. Which means that the derivative of 2 2 is the derivative of 3, right? This is decreasing the whole time. All right, so 2 is the derivative of 3, is 3 prime. And then what is red? Red's not the derivative of anything, so we know red is f double prime already. And so here I have it summarized. We have blue is the derivative of green, red is the derivative of blue, so therefore green is the original function, and then blue is the derivative function. Okay, just be careful with those. Those can get a little confusing, I think, at times. 32, let f be this function. What is the value of c for which the instantaneous rate of change is the same as the average rate of change? So average rate of change, again, is slope between 2 points, f of 4 minus f of 1 over 4 minus 1. You just use your calculator to get those. And we want the instantaneous rate of change, f prime, to be equal to that. That's just 1 plus 1 over x. So find this numerical value, set it equal to the derivative, and I found that to be, here's my average rate of change value. Notice again how I did not round it, and then I graphed these and found the intersection point and got x equals 2.164. Second time we've seen a question like that, where you want to show that those two things, where they're equal. 33, g is differentiable and always negative, and f prime is equal to that, which of the following is true? And then it asks us questions about f, about maxes and mins and stuff. So what we want to analyze here is a sign chart, x minus 2 times x plus 2 times g of x, but g of x is always negative, so I'm just going to put times a negative right here, okay? Because when we make our sign chart, that's going to be important. So here we have f prime, f, critical points of negative 2 and 2. Pick negative 3, and this will be negative, negative, negative. 3 negatives means that's going to be negative, so the function decreases. Pick like 0, and you get negative, positive, negative, which is positive when you multiply it all together. Oops. Positive. And then pick a number like 4, positive, positive, negative. So again, that's going to be negative in the end. So f has a relative max at x equals negative 2. Nope, we got a min at negative 2. F has a relative min at -2, yes, and a relative max at 2, yes. So it seems like that's our answer. Let's go through the rest, though, and see why they're not the answer, if B is in fact the answer. Always a good idea, because you could make a mistake early on that you might correct later. F has relative minima. That's just the plural for minimum. So it's saying there's a minimum at both places. No, there aren't. This is saying there's a maximum at both places. No, there is not. And it cannot be determined. That is also not true. So the answer is, in fact, B. Okay, moving on to 33. Oh, no, that was 33, sorry. Looks like these numbers don't match up. Oh, yeah, they do. Sorry, I don't know what I'm thinking. All right, we're on 34. Okay. 34, a differentiable function has these properties. What is an estimate using the local linear approximation? Okay, so all they've done here, if they've given us a point, 5, 3, and a slope of 4 from this, and a local linear approximation is just a tangent line. So we write the equation for the tangent line, y minus 3 equals 4 times x minus 5, and then use it to estimate f of 4.8. So remember, whatever this function happens to look like, we turned it into a line at a point close to x equals 5. 4.8 is close, so now we just plug in 4.8 for x and calculate that, and I'll let you go through that arithmetic to save you some time. Okay, but I'll show you the answer here, 2.2. And let's see, 35. Let g be the function given by that. On which of the following intervals is g decreasing? So if you want to know if something's decreasing, find when its derivative is negative. The derivative of an integral is just the function on the inside. So graph that and find when it's negative. Okay, and you should end up with that interval if you do it correctly. The answer is D. 36, we've got some information here, f of 2, f of 5, and f of 9. Which of the following must be true? So our y value changed from a -5 to a +5 back to a -5. Pay attention to the x values. I don't think they would do this, but these x values do go in order. That would be important so for what we're doing here. Okay, so it has at least 2 zeros. Well, if it went from -5 to 5 and it's differentiable, which means it's continuous, then by intermediate value theorem, it had to equal 0. And then when it goes from 5 back to -5, it would have to equal 0 again. So it has at least 2 zeros, yes. And again, it says at least because we don't know what the values are between 2, 5, and 9. It could be all sorts of things. The graph has at least one horizontal tangent. Since from -5 to 5, the graph had to go up, and then from 5 to -5, it had to go back down, and it's differentiable. It can't have a corner there, so it has to have a horizontal tangent since it's differentiable, so that's good. And then this was supposed to say, for some c between 2 and 5, f of c must equal 3. Between 2 and 5. And so since it changes from a y value of -5 to 5, it seems like that one should be true too. I don't know if I'm reading that question correctly. Yeah, so it was all 3. Okay, yeah, that's how I read that. It should have shown up correctly online for you guys probably. I think some stuff got lost when it translated over. All right, 37. This one, there's a shortcut here. Oops. Which is, well, all right, let me show you the long way first. But you can find k by doing, in the end, k just equals natural log of 2 over 10. 2 is because it doubles, and 10 is because of the number of years. But I'll show you why that works here. I'll just show you on here since I already have it worked out. I did a separation of variables, but you can memorize this result, okay? Or you can say that, oh, sorry, never mind. All right, so I did separation of variables right here, and then did the antiderivative both sides. And then at t equals 0, our initial population would be y sub 0. And so I find my c value to be this, and then I plug that into my equation right here from there. Okay, that's where that came from. And then I just solved this for y. I wrote this as exponential e to this power equals y, and then since that's part of my power, I can bring the y sub 0 down in front. And you just end up with this, which is like exponential growth. And then if it doubles every 10 years, so notice where these numbers are now. If it doubles every 10 years, that means my final population will be twice my initial population, which is where that comes from. And then this equation just stayed the same, except I plugged in 10 for t. And so then you get the y sub 0's cancel here, and you just end up with this equation, which you can then solve for k. And when you write that as a log, you get k equals natural log of 2 over 10, which as a decimal is what the final answer is. But you could just memorize this result, that k equals natural log of 2 over 10. Or in general, if it doubles or triples, whatever you want to call that, let's just call that like the growth, I'll call it g. K equals g over t, number of years, or t equals g over k. I don't know if that makes sense to you or not, but in the end, the result's always just going to be this, just those numbers change depending on if it doubles and then how many years it is. Okay, so that's 37. 38, a table of values for a continuous function f is shown above. If 4 equal subintervals are used, which of the following is a trapezoidal approximation? All right, so now here we have, this is supposed to say integral from 0 to 2. So now we do have equal subintervals, and we already did a trapezoidal approximation without equal subintervals. But now since they're equal, we could do the trapezoidal rule. If you don't know the trapezoidal rule, then just do every single trapezoid one at a time. But the trapezoidal rule is going to be 1/2 the first base, which is 3, plus 2 times the second base, which is also 3, plus 2 times the next base, plus 2 times the next base, plus the last base only once. And then times our base length, which is 1/2 or 0.5 for all of that. So just sum all that up, okay, and calculate that and get a final answer. Show it to you here real quick on this key. There you go. You can pause the video if you need to see that better or for a longer amount of time. Let's go through all the way to number 40 on this video, and then I'll make a third video. The graph of the function f shown above consists of 2 line segments. If g is the integral of f, then g of -1. So g of -1 is just the integral from 0 to -1 of f of t dt. 0 to -1 is this area, but since we're going left and that area is above the x-axis, the answer is actually going to be negative. So find the area of that triangle, and you should just get -1. And last question on this video, number 40. Let f be the function with that derivative. How many relative extrema does f have on 2 and 4? So remember, relative extrema are maxes or mins. So look at this graph on this interval only from 2 to 4 and see how many times it changes signs. So just graph it and look how many times it crosses the x-axis and changes signs. And you should end up with 4, hopefully. All right. I hope this is helpful. Good luck.